Channel. Today we're going to be solving a complex numbers A-level maths or further maths problem. And this also covers IB complex numbers in AAHL. And it says that let x and y be real numbers and omega be one of the complex solutions of the equation z cubed equals 1. They want us to evaluate 1 plus omega squared and omega x plus omega squared y all times omega squared x plus omega y. We can start by writing out the actual equation that we're given, and we can move the one to the other side. From this, we can use the difference of two cubes formula to factor this equation, and we get this, that z cubed minus 1 equals 0 implies that z minus 1 times z squared plus z plus 1 equals 0. And if we look at part A, you can actually see that omega is a root of the equation, because and then if we plug in omega here, we're going to get omega squared plus omega plus 1, which will give us 0 because of the factorization. Hence, we can say that because omega is a root of the equation, 1 plus omega squared equals 0. That's 2 marks. And then part B, we have this product right here. We can start by expanding the product, which we can do by doing the first expression times the second expression, so we get omega x times omega squared x plus omega x times omega y, and we repeat it for omega squared y, like we've shown here. Now, if we simplify this expression by multiplying and combining the terms and the exponents, we'll get this expression, omega cubed x squared plus omega squared xy plus omega to the fourth xy plus omega cubed y squared. Now, from the original equation, we know that if z cubed equals 1 and omega is a solution to the equation, then omega cubed must also be 1. So, we know that omega cubed equals 1. And now, if we want to figure out omega 4, we can just do omega cubed times omega, right? Because then the power will go by 1, that's our exponent rule. And since omega cubed equals 1, it's going to be 1 times omega. So, omega cubed equals 1, then omega to the fourth is going to be omega cubed times omega, which is equal to 1 times omega, which is omega. So we know that omega to the fourth is equal to omega. Now we can actually factor out some stuff here. So we see that there's an x squared and a y squared, and they both have a common factor of omega cubed. So we can factor that out. But omega cubed is equal to 1, so we can just leave that as x squared plus y squared. Now we have, if you look closely, we have xy times omega squared plus omega to the fourth, which is equal to xy times omega plus omega squared, because we found that omega to the fourth was equal to omega. So this should be actually an omega to the fourth, but since they're equal to each other, we take it like this. Now we use the result from part A, because if 1 plus omega squared equals 0, then omega plus omega squared equals minus 1. And if we plug in minus 1 into this factor right here of omega plus omega squared, we'll get minus xy, and hence the final solution is x squared minus xy plus y squared. So in summary, here in part A, we factor out the complex equation. We substitute in omega. In part B, we use our FOIL technique to expand. We simplify the expression, and we use the property of this complex number to find that omega to the fourth is equal to omega. And then we use the value from part A in this step right here with x squared plus xy times omega plus omega squared plus y squared. We use the result from part A, and in all, we get the result x squared minus xy plus y squared. Thank you for watching, and like and subscribe if you want to see more videos like this, and see you next time.